Additive versus multiplicative relationship notes. So we're going to start with the whole additive side, and then we'll go over to the multiplicative side. So anytime we're talking about a relationship between the two variables, it's important to remember which variable is the independent and which is the dependent. So over here on the additive side, we have y. This is always the dependent variable. Which means it is the answer. It's what we're trying to find. That means that x is the independent variable. So it is the value that we are changing. And this a on the end is the rule. So this is how we are constantly changing the independent variable to get to the dependent variable. In an additive relationship, the same number is being added to the independent variable to get the dependent variable. So again, we're going to add a constant number to the independent variable to get our answer. So here's our example. A party store emailed a coupon to their customers. Receive 2 free balloons with any balloon order. Represent this relationship between the number of balloons ordered, x. So number of balloons is our x. And the total balloons, which is y. So again, it makes sense that the total is the answer. The total depends on how many balloons we buy. Okay? And it told us we got 2 free balloons every time we ordered some. So let's say we go in and we order 1 balloon. We paid for 1, but we got 2 for free. So we're leaving with 3 total. Let's say we go in and we buy 4. We buy 4. We got 2 for free. We're leaving with 6. Let's say we go in and buy, 10. We leave with 2 free. So we have a total of 12. And then let's say we go for 7. We leave with 9. So here they told us that the balloons ordered is that x value, that independent, and the total is the y, which is that dependent. So again, your total right here depends on how many balloons you paid for. We're going to take this table that we just made with our numbers, and we're going to use it to create a graph of the values. So it's important to remember when you're graphing points, you have to have an x and a y value. So your x is this horizontal, and your y is the vertical. So up here we wrote that x represents the balloons ordered. And y represents the total you're leaving with. So when you're plotting a point, remember it's always x then y. So run then jump, crawl then walk, or you can think about it like the alphabet. So our first point here is 1 for the x value and 3 for the y value. So 1, 3. The second example we have is 4, 6. And then we did 10, 12. Then we backtracked and we did 7, 9. Now, I have a question for you. If you bought 0 balloons, technically, would you get any free? The answer is no. However, for our mathematical sentence, if you bought 0, you would still add 2 to that. So the y value would be 2. So we have this dot right here at 0, 2. So a rule of thumb, an additive relationship, or an additive graph, will go through the number that is being added on that y-axis. So here we're adding 2 each time. So you can see we start with this point at 0, 2. And then summarizing, this is an additive relationship because 2 is being added to the independent variable to get that dependent variable. So if we use our example from up above for the equation, we're always trying to find y, and y can be found by taking that independent variable x and adding 2. On the other column for our notes, we have this multiplicative relationship. So it kind of tells you the difference based off what the words are. So y is still going to be dependent. That never changes. The dependent variable is always y. It is always the answer. A is the rule, and x is that independent variable. It's what we can change. So each independent variable is multiplied by the same number to get the dependent variable. So I guess we didn't talk about it, but whenever a letter and number are touching like this means to multiply. Okay, so we have an example. A Starbucks barista uses 5 pumps of sweetener in every 1 cup of coffee. Represent the relationship between the number of coffees, x, and the total pumps of sweetener, y. So same thing, our cups are going to be the x. So these are the independent. And then the pumps of sweetener are the y, which are the dependent. And now we're going to use this information to fill in the table. So we're going to use that relationship they gave us to start. If we buy 1 cup of coffee, we're getting 5 pumps of sweetener. If I buy 4 cups of coffee, we're getting 20 pumps of sweetener. If we buy, 7 cups of coffee, get 35 sweeteners. And if we purchase 10, we're leaving with 50 pumps of coffee. So same thing, we always plot a point as x, comma, y. Our x in this situation are the cups of coffee. And the y, or the vertical, is that sweetener. So let's fill in what we know. Our first point is 1, 5. So we're going to go to 1 cup of coffee, and we're going to go up to 5. So it's kind of in that space right there. Then we're going to 4 cups of coffee, and we're going up to 20 pumps of sweetener. 7 cups of coffee is 35. So also in that space. It's not perfect, but it's close enough. And then our last one was 10 cups of coffee, and it goes all the way up here to 50. Now, on this situation, we're multiplying. So thinking back, if we have 0 times 5, that's going to equal 0. So whenever you have a multiplicative graph, it's going to start at this origin. It has to go through the origin, or that point 0, 0. So a multiplicative graph, will always go through the origin, which is that point 0, 0. The equation for this problem, so how we solve it, we're always trying to find y, the answer. And we got all of our y values by taking 5 and multiplying it by x. And then this is a multiplicative relationship because the independent variable is being multiplied by 5 to get that dependent variable. So some big takeaways here. To plot a point, it's always x, then the y value. Equations can be additive or multiplicative, depending on if you're adding or multiplying. And you always add or multiply to the independent variable to get that dependent variable answer.